Now we have two cones. These cones represent a pawn charge. So I put the coin here, and also I put another coin here. We want to have a potential difference between the two coins. This is the power supply. This is the negative. So if the cable is not long enough, you can extend the cable like this. One thing important, when you extend the cable like this, make sure these two parts, they won't touch each other or other metal. So put this, yeah, we just leave it here, yep, for the time being. Next, this is the positive part. Okay, here. Now, this is the power supply. If we turn on the power supply, you should see 5 volts. If this is not 5 volts, you can change the voltage. In this experiment, we are going to use 5 volts. Put this one on top of the first cone, and your partner in your team put the other one on the other cone. Now there will be a potential between this cone and this cone. And also there will be electric field which will happen along this conducting paper. We want to know the potential at each point of this conducting paper. So therefore we have to set up the measurement. We're going to use the multimeter here. So let's turn off this one first. Now to set up the measurement, we use the common here. We want to use the potential difference with respect to this point. So we will connect this one to here. So this point, or effectively this, and this will be connected, and they will have the same potential. It's a pop. We connect this one to the output of the multimeter. We are going to measure the DC voltage. So if you look at your multimeter, this means DC. And because we're using 5 volts, so we set the selector to 6. It means the maximum voltage it will, at this setting, is 6 volts. We'll turn on the multimeter again. I'm going to put the positive on one of the cone, and your partner, we're going to put the negative. Now, let's do the quick test. Remember, the voltage from here to here is 5 volts. We can do the quick test. Put it here, 0, here, 5. Okay. Now make sure you press this one down and you don't lose the contact. Now it means from here 0 to here 5 volts. However, if you measure the voltage near the cone here, you see you only get 4.6 volts. And even you a little bit closer, 4.7. So what it means is there's some potential drop between the cone and the paper. So even at the cone here, you get 5 volts, but you won't get 5 volts at this point. Okay. Each time there will be slightly different. It depends on the contact and also your surface property of your cones. The next thing is we do some quick test. If this is 0, or here, if this is 0, and if this is 4.6, 4.7, in the middle, this line, along this line, it should be half. So if we find the middle point, it should be somewhere here. Yep, this is 2.5, so roughly not exactly half the value. Okay. Now, also, if we put this one, this is about 3.7, 3.8, and this is about 1.5. So the task of this experiment is we want to map the potential at each point on the paper. And from here, we can find the so-called equipotential line, and from there we deduce how the electric field will look like. Start the measurement. Three point four, 3.44, 3.46, 3.49, 3.53, 3.58, 3.60, 3.64. Okay, so etc. You start from here to here and all the way up here. You measure the potential, the reading from your multimeter, and organize your data in the Excel file.